In today's lesson, we are going to talk about exponents. This is section 2 of our review unit. The essential question is, what are the properties of exponents and how do you use them? The first property that we will discuss is the negative exponent rule. This rule simply states that if b is any real number other than 0 and n is a natural number, then b to the minus n power is equal to 1 over b to the positive n power. An example of this would be 5 to the minus 3 power is equal to 1 over 5 to the positive 3 power, or 1 over 125. The next is the zero exponent rule. Now this rule simply states that if b is any real number other than 0, then b to the 0 power is equal to 1. An example of this might be 7 to the 0 power is equal to 1. The next is the product rule. Now this simply states that if b is a real number or algebraic expression and m and n are integers, then b to the m power times b to the n power is equal to b to the m plus n. An example of this might be 2 to the second power times 2 to the third power is equal to 2 to the 2 plus 3 power, or 2 to the fifth power, which is 32. The next is the power rule. Now this states that if b is a real number or algebraic expression and m and n are integers, then b to the m raised to the n is equal to b to the m n. An example of this might be 2 to the second power raised to the third is equal to 2 to the 2 times 3 power, or 2 to the sixth, or more simply 64. The next is the quotient rule. Now this rule says that if b is a non-zero real number or algebraic expression and m and n are integers, then b to the m exponent divided by b to the n exponent . If b is a non-zero real number or algebraic expression and m and n are integers, then b to the m over b to the n is equal to b to the minus n, b to the m minus n. For example, if I had 2 to the 8th divided by 2 to the 4th, this would be equal to 2 to the 8 minus 4, or 2 to the 4th, which is simply equal to 16. The next rule we have is products raised to powers. So if a and b are real numbers or algebraic expressions, and n is an integer, parentheses a times b parentheses to the n is simply equal to a to the n times b to the n. For example, let's say we had the product minus 2y, all of that raised to the 4th power. That would be equal to minus 2 to the 4th times y to the 4th, or 16y to the 4th. So the last rule we have will be quotients raised to powers. So if a and b are real numbers, b is not equal to 0, or algebraic expressions, and n is an integer, then parentheses a over b raised to the n is simply equal to a to the n divided by b to the n. So, for example, parentheses minus 3 over x, all raised to the 3rd power, is equal to minus 3 raised to the 3rd power divided by x raised to the 3rd power, or simply minus 27 over x to the 3rd. So, now, how do we use what we've learned to simplify exponential expressions? So first, we have to decide when is an exponential expression simplified. Well, there are certain categories or certain factors that make it simplified. The first is that no parentheses appear. The next is that no powers are raised to powers. The next is that each base occurs only once. And the last is that no negative or zero exponents appear. So let's look at an example. For example, look at what's on the screen right now. We got parentheses minus 3x to the fourth, y to the fifth, parentheses, all of that raised to the third. So we want to get rid of the parentheses. We want to use the rules for exponents and simplify this. So initially we're going to raise everything inside the parentheses to the third power. So that's minus 3 to the third, x fourth to the third, y to the fifth to the third. So if we raise minus 3 to the third power, we simply get minus 27. X to the fourth raised to the third power, remember we multiply the exponents, so it's 4 times 3 or 12. And same thing with y to the fifth raised to the third, we multiply the 5 times 3 and we get 15. So our final simplified answer is simply minus x to the 12th, minus 27x to the 12th, y to the 15th. So let's look at another example. We've got parentheses minus 7x, y to the fourth, parentheses, times, parentheses, minus 2x to the fifth, y to the sixth, parentheses. Let's simplify this. So now, if we group factors together with the same base, in other words, group the x's, group the y's, and group the numbers together, we have minus 7 times minus 2, then x times x to the fifth, then y to the fourth times y to the sixth. Now this gives me 14. Now it's x to the sixth because we're going to add the exponents. X is actually x to the 1 times x to the fifth, so we add 5 plus 1, that gives us an exponent value of 6. Then y to the fourth, y to the sixth, 4 plus 6 is 10. So the final answer is 14, x to the sixth, y to the 10th. For our next example, we'll have the quantity minus 35x squared y to the fourth divided by the quantity 5x to the sixth, y to the minus 8. So again, if we group like factors, or factors with the same base, we're going to have minus 35 over 5. We're going to have x squared over x to the sixth, and we're going to have y to the fourth over y to the minus 8. All right, now in terms of exponents, remember that the quotient rule says we subtract exponents. So now we have minus 7, x to the minus 4, because that's 2 minus 6, y to the 12th, which is 4 minus a minus 8. Well, if we remember our rules for simplifying exponential expressions, we can have no zero or negative exponents. We've got a negative exponent here, so we have to change that. So our final answer is minus 7 y to the 12th over x to the 4th. The negative exponent 4 we simply bring down into the denominator and it becomes positive. So here is our final example. We've got the quotient 4x squared over y, and that whole thing is raised to the minus 3 power. So one of the ways we can do this is simply to take the fraction, invert it, and make the exponent positive. So instead of having 4x squared over y to the minus 3, we have y over 4x squared to the positive 3. So this simply becomes y to the third divided by 4 to the third times x squared to the third. So the final answer here is y to the third divided by 64x to the sixth. So now I would like you to simplify the following expression and put your answer in the drop box.